New research has shown a surprising likely purpose for Bronze Age metal daggers. Organic residue analysis revealed the function of Bronze Age metal daggers, according to the new study, which was published in the journal Scientific Reports. The groundbreaking new method that allows organic residue to be extracted from ancient metals has shown that Bronze Age daggers were primarily used for processing animal carcasses. Daggers first appeared in the early 4th millennium BC, with copper and bronze versions widespread in Chalcolithic and Bronze Age Europe, but archaeologists have long debated what they were used for. For most of the 20th century, the prevailing opinion was that, by and large, daggers were non-functional symbols of identity and status on account of their frequent placement in apparent warrior graves. By contrast, other researchers maintain that daggers were functional weapons for close-quarters combat, as implied by rare injuries on prehistoric skeletal material. Other experts suggested different uses, but the debate could not be settled due to the lack of a targeted scientific method showing what tasks daggers were created for and on what materials they were used. An international team led by Dr. Isabella Caricola and Professor Andrea Dolfini at Newcastle University has now developed a suitable methodology. The technique, an adaptation of residue extraction and characterization protocols previously used on ceramic, stone and shell artifacts, involves the application of picrocerious red, or PSR, a solution used in microscopic analysis to stain biological tissues and collagen from millennia-old archaeological contexts, to 10 copper alloy daggers from Pragato, a Bronze Age site in Italy. Pragato is an expansive domestic site recently excavated near Bologna. The site is part of the broader Terra Mare settlement system, which characterized human occupation of the Po Valley in northern Italy from about 1650 to 1200 BC. Terra Mare sites are villages ranging from 1 hectare, 2.5 acres, to 20 hectares, just over 49 acres in size. They were normally built near rivers or streams whose courses were diverted to fill the ditches surrounding the villages. Embankments and palisades encircled most sites. At Pragato, controlled excavations investigated a 6,900 square metre area corresponding to the southern portion of the Bronze Age village. A fire swept through part of this area in antiquity, destroying, yet at the same time preserving for posterity, the remains of 9 houses with all the objects they once contained, including more than 150 bronze items. 10 daggers from this remarkable cache were selected for the research. The team isolated organic residue on the cutting edges, blades and hafting blades of the daggers. These were observed under several types of optical, digital and scanning electron microscopes and chemically characterized by energy dispersive X-ray analysis. Using PSR as a staining material allowed the team to identify collagen and associated hard and soft tissues, suggesting contact with animal products. They isolated the following micro-residues: 1. Collagen, including striated muscle tissue, bone tissues and bundles of tendon fibers, and 2. Fur/hair fibers and plant materials interpreted as remnants of dagger sheaths. The team then extracted the plant material for botanical analysis. This revealed features that are typical of 2 species of broadleaf plants, one probably being older. The orientation of the wood element suggested that prehistoric crafters wove together small strips of young plant branches to build the dagger sheaths. To corroborate the analytical results, the team carried out wide-ranging experiments with purpose-built dagger replicas. First, they asked experimental archaeologist and bronzesmith Alberto Rossi to prepare 8 daggers based on Chalcolithic and Bronze Age templates, including blade dimensions close to the Pragato specimens. He cast 3 daggers from 4% tin bronze, a compositional proxy for early to middle Bronze Age low tin alloys, and 5 daggers from 10% tin bronze, reflecting middle to late Bronze Age high tin alloys. He then hammer-hardened all replicas, hafted them and sharpened their cutting edges with a whetstone. Isabella Caricola used these replicas for cutting, scraping and drilling activities, lasting 3 to 5 hours each. She employed 4 daggers to process animal bone, tendons, muscles and cartilage before isolating the residue and studying it under a microscope. She also selected 2 daggers for butchering and carving the carcasses of a pig and a red deer in order to document associations between the residues. Finally, she used 2 daggers to work green and dry wood and harvest 2 species of wheat. 7 to 10 days afterwards, she observed oxidation structures appearing on top of the plant and animal residues, ranging in colour from orange/orange-green to black. Microscopic observation and chemical analyses of these structures return results comparable to what have been observed in the archaeological daggers, confirming the interpretation proposed. Overall, the researchers demonstrated that prehistoric metal daggers were primarily used to process animal carcasses. The evidence shows interaction with both hard and soft tissues. This suggests that the daggers were used for a wide range of tasks that followed and perhaps included the slaughter of livestock and game, including butchering the carcass and carving the meat from the bone. The evidence tallies with useware studies of early metal daggers, showing a widespread desire to keep these tools sharp. It is also in line with Pragato being a settlement site where animal husbandry was extensively practiced, and Caricola and Dolfini's own experiments, which documented how effective daggers can be in detaching soft tissue from the bone. Significantly, this conclusion is independently validated by the microware analysis of butchered animal remains from several prehistoric sites, which often display cut marks inflicted by metal blades. Of course, daggers may have had further functional and symbolic uses, and they probably did. And this is not to mention that food preparation was a vital and perhaps ritualistic endeavour. In Chalcolithic and early Bronze Age Europe in particular, daggers might have been utilised as close-range weapons and iconic markers of gender identity. This is hinted at by warrior burials and rock carvings depicting daggers along with other weapons and paraphernalia of male identity. Andrea Dolfini said, "The research has revealed that it is possible to extract and characterise organic residues from ancient metals, extending the range of materials that can be analysed in this way. This is a significant breakthrough as the new method enables the analysis of a wide variety of copper alloy tools and weapons from anywhere in the world. The possibilities are endless, and so are the answers that the new method can and will provide in the future." Isabella Caricola added, "At present, residues can only be extracted from freshly excavated metals that have not been contaminated through handling, cleaning and conservation. It is therefore important that researchers interested in organic residue analysis act as soon as the object emerges from the soil. They should place it in a clean bag, leaving on any soil residues, and contact a specialist at the earliest opportunity." So what do you think of the analysis? Let me know in the comments below, and don't forget to like, share and most importantly subscribe. And thanks for watching.